prayer.
Of the Son and of the Holy Spirit.
Amen.
Heavenly Father, thank you for today. Thank you for the gift of life. Father, as we are going to this math lesson, I pray that you enable us to understand everything our teacher is going to teach us, and may you give me more knowledge, more things. I've asked all of these and those requests deep down in our hearts. I pray that you may see them and grant them. In Jesus' name, as I've prayed and believed. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Thank you very much, Sherry, for that prayer that you have given us. And I hope you can see what is on the screen, and you can see where I'm going to be writing our notes. So I can zoom in there. There's a lot of light. Let's fix that. Okay, that's okay. All right, so tell your friends, your relatives, your schoolmates, your classmates to come and attend, neighbors and what, to come and attend this lesson, because this is the third last topic, areas and volumes, areas and volumes of solids. Okay, so last time the lesson that we had, it was a revision that was making a climax of the 3-dimension, and I think you went through also the video that I uploaded and you revise. So if you, in case you have forgotten, you can go back, you put some few bundles, maybe 20 MBs, you go back and watch those videos, and then you can remind yourself. If you feel like you are revising and then you are not getting the things, you can go back and check those videos. You just have to select your class, look for your class, and then select the subject math, and it will display all the math videos, all of them. So they are saying that areas and volumes of solids, the solids under consideration include the following. So which solids are we going to look at? We are going to look at over 5 solids, but we have here 5 solids. So there are prisms, there's a pyramid, there are prisms, there is a pyramid, there is a cone, there is a cone, there is a sphere, there is a pipe. So we have 2. So the solids to look at are the solids that we are going to look at. We have prisms, we have pyramids, we have the cone, okay, and we have the sphere, and then the pipe. Okay. So those are the solids that we are going to look at today. So under these solids, we shall be able to look at 3 things: the areas, the volumes, and from the volumes or from the areas, we shall also look at the nets. But when you're looking at the area, we shall look at the surface area of a prism, the surface area of a pyramid, of a cone, and also we shall look at their volumes. We are looking at solids. We are looking at solids. What do they mean by the term solids? By something called a solid. For instance, if I have a sphere, let me pick here a sphere and I'll show you.
Your noise can't reach there.
So suppose I have a sphere like this. This is a sphere, that's sphere. So this sphere, we are looking at something that is solid, not having air inside, but also inside it is fully covered with maybe with a material. So if it is a metallic sphere, then even inside this kind of sphere, it is a metal. It is a metal. So it is a solid. The same way how you may see an egg, a boiled egg, that inside that egg it is fully covered. That maybe the air that is there is very small, but whatever that is inside is fully what? Is fully covered. So no air. So it is a solid. If you are looking at a prism, the same way how you see those prisms, maybe the prisms that were built by Egyptians, those prisms, I mean the pyramids, those pyramids, the way they look like, that inside they are fully covered with maybe clay or what. So it is a solid. It is a solid. They are solids. So we are going to look at the surface area. Now, surface area, if it is a sphere like this, we shall look at the surface area, the outside area. How would you get to the outside area of the sphere or of a cone or a pyramid, like that? So we are going to start with a prism, slowly by slowly, and then we shall go to a cuboid, looking at their surface area. Then we shall go to the cylinder. As I told you, there are very many shapes and pyramid like that. So that will be surface area only. And later on, we shall look at the volumes of those solids one by one. So let us start with surface area of solids. So in our books, we are writing surface area of surface area of solids. So here they are defining surface area of a solid as the sum of the areas of all the surface of the solid. The sum of the areas. So if this is a sphere and they are telling you to find its surface area, then what you can do is that you may not get, I don't know what you can use. Okay, measure what? I don't know, you cannot measure the surface area here. But what you can do is that you can have, let's say, you can have small partitions or small areas drawn on that sphere. So if this is a sphere, you can have small areas, let's say small areas, something like this, small areas that are on this sphere. And these areas, you can find their area. You can find the area of this surface that I've drawn here. So you can have very many of them. And once you have areas of very many of these small areas, then at the end, if you add up their areas, you are able to get to the surface area of the whole what? Of the whole shape of the whole solid. So we shall be looking at getting the area of one small thing here, and then we multiply by what is there, how many small areas are there, and then we shall add them up and we get the total surface area. That's what you know. So that's why they are saying the surface area of a solid is the sum of the areas of all surfaces on a solid. So there are very many surfaces. You can have small demarcations for which those small areas can be measured in terms of maybe length times width. And then those small areas, you can count them how many they are, and after getting the area of one, then you multiply by how many they are. So it is the sum, or you add up their areas. So it is the sum of the areas of the surfaces of a solid. That's what you have to know. The surface area of a solid. So we are going to look at surface area, of a prism, surface area of a prism. And I would say here that Roman number 1, we shall start with a prism, or prism, or prisms, or something. So a prism is a solid which has uniform cross-sectional area. A prism is a solid that has uniform cross-sectional area. Maybe that is very important, that it is a solid, it is a solid with uniform cross-sectional area. And I'm going to be giving you examples of solids that are in form of prisms. So these include the rectangular prism, the cubes, the cuboid. So you can have a rectangular prism, you can have a prism in the form of a cube, You can have a cuboid, all those are prisms. We have a triangular prism, so we are triangular prism. There is also what we call a circular prism or a cylinder. Those are prisms. So they have a uniform cross-sectional area. What do they mean by a uniform cross-sectional area? So if you are to look at a rectangle, if a rectangle is a rectangular prism, then that rectangular prism, when you look at the area of a rectangle, then that area of a rectangle is what gives the cross section. So it means that all the way throughout, the prism will be having a uniform cross-sectional area of that rectangular prism. Maybe we can see what are rectangular prisms here. Let's see, because in this book it's not there, but you can check here. Rectangular prism, rectangular. So we can have a rectangular prism like this one. You see under images. Okay, so these are rectangular prisms. You can see this here. This is a rectangular prism here. A right rectangular prism. It's a rectangular prism. Also, this is a rectangular prism. So the area of, you can look at the area of this rectangle. That area of the rectangle will give you the area of the cross section. Okay. What else? They talked about the, okay, we have also the cubes. So you have the cube. So you can have a cube, the cube prisms, cube prism, something like that. Okay, something like this. We have seen these cubes that people like playing with. So these are prisms. It is in form of a cube, but it is a prism. Why? Because it is a solid within inside there. And here they are giving us different shapes here. So this is a cube. They're all. This is a pyramid. So, okay, here they are just giving us different prisms. But here you can see we have a triangular prism. This is how a triangular prism looks like. Maybe I can put it here and see triangular prism. Triangular prism. Okay, so this is a triangular prism, something like that. It's a triangular prism. And Cynthia, hope you are following. But this one can give us the whole overview of what prisms are. So we have the rectangular, we have the cube, the rectangular, the hexagonal, so this is, I think this is 1, 2, 3, 4, 5, 6. This is hexagonal, this is also hexagonal, and like that. This is a cylinder, this is a cone. So all these, most of these are prisms. So this is what we are going to look at. How do you find the surface area of this, surface area of this? How do you find surface area of the cone? How do you find surface area of this? All of this one here, which is here. So we shall look at that. Okay, let's go back. So you have seen, so it is a solid with uniform cross-sectional area, and this includes, we shall look at rectangular prism, rectangular prism. And now for this case, you should be, you know what a rectangular prism is. It is in form of a rectangle. Cubes and also cuboids. We have a triangular prism. You have seen a triangular prism? Members, have you seen a triangular prism? Yes?
Yes, teacher.
What of a circular prism? Circular prisms? You have seen? In form of cylinder.
Yes.
In form of cylinder. There is no cylinder. So cylinders. Those are the prisms that we are talking. Prisms that we are talking about. So we are going to be able to find their surface areas. Okay. All right, let us proceed. So they are saying that the surface area of a prism is found by using this three steps. One, find the area of the cross section and multiply it by 2. Find the area of the cross section and multiply it by 2. So you have to find the area of the cross section and multiply it by 2. Then 2, find the area of each rectangular sides of the face and add up these areas. For the case of a cylinder, find the area of the curved surface. Wow, this is interesting. And then the second one, add up the results and get the surface area of the prism. So all those steps, those 3 steps, we are going to do them one by one, and I'm going to show you what each one means. What each one means. All right. Okay, so let us write the steps to find the surface area. Steps followed. Steps forward to find the surface area. So what are those steps? Number 1, you have to find the area of the cross section and multiply it by 2. Why do they multiply it by 2? So number 1, find the area of cross section and multiply it by 2. Multiply it by 2. Right now, some people are asking themselves, what is a cross section? What is a cross section? What is a cross section? So let me first draw for you one diagram here. I'll do this and this. Okay, then I'll put this here. Then I don't know what you are writing, but let me draw one diagram here. Look for a rectangular. Rectangular. Let me use this here. Okay. So we have this. Okay. You have a right rectangular prism. Let's see if there are very many. Okay, we have this one, and I'm going to draw that, and I show you why we multiply it by 2. So just very fast for this step, and I show you what a cross section is. So I'm drawing the first one there. Okay, so you should be able to, that's what I'm saying, you should be able to have a ruler here, a pencil, and a rubber in case you make a mistake. So I have something like that. So what is the cross section? So this is the cross section, this part here that you're seeing. Let me shade it for you. This one. So you find the area of that. You find the area of that. Or you can find the area of, and you multiply it by 2 because there are 2 cross sections. So the shaded parts, these are what we call the cross sections. These ones here. Call the cross section. So in other words, this is the cross section from here. This is what makes up the solid. If it is a rectangle like this, and you cut it here, if you cut it here like this, still you get the surface of the parts where you have cut. They will still appear in form of this. So those surfaces will be also rectangular. So if I cut here like this, I will have a surface there, just like this. So it means that this part, this kind of shape that you're seeing, this is what we call a cross section because it is everywhere. It is inside there. Everywhere it is the same figure inside there. So it is a cross section all throughout from the top to the bottom. That's a cross section. Okay. So we multiply by 2 because they are 2. That's why there are 2 there. There are 2. So there's this and this. So find the area of this one and then multiply it by 2. That is the first step. Then the second step, let us see the second step. If you have a question, you can ask. Have a question, you can ask. So let us see the second step. The second step, they are saying find the area of each rectangular side. So find the area of each rectangular side face, and add up these areas and add up these areas. Okay, so find the area of the other rectangular sides. How many rectangular sides are there? Suppose it is this shape. How many other rectangular sides are there? Put up your hand. There are how many? Put up your hand. How many other rectangular sides are here? Are on this figure here. How many other rectangular sides are here? Apart from these ones which I have shaded the cross sections, how many the other rectangular sides are there? Yes, Bright.
4.
They are what?
There are 4.
They are 4, correct. So they are 4. So you can see from that diagram there that they are indeed 4. If I may draw it here, let me see whether I can draw it here. I'm very stubborn. I can draw it here like this, like that. Okay. Do that. Okay. Olivia, are you there?
Sure, I'm there.
Very good. So you should follow now. Very good what you are doing. Okay. If I have this, so there are 4 sides. There are 4 sides. So we have this one here that is seeing me. We have this one here. This is 2. We have the other one inside 3, and we have this one, this other side 4. Okay, so there's this one here. There is this one here. There's this one inside here. And then there is also this other one here. So there are 4. There are 4. So that's why we shall have. So we shall get 1, or we can just multiply 1, get the area of 1, and then multiply it by 4. So here there are 4 surface sides. In that case, there are 4 surface sides. So you get the area of 1, and then you multiply it by 4. Or you get one area, and then the other area, and then the other area, and then the other area, and then you add, and then you have the area for those surface areas. Then the last part is you add up the results. Which results you add up? The area of the cross section, the areas of the cross section, plus the areas of the surfaces, the other sides of the other surface. Okay. So we go to 3. 3 says that add up the results to get the surface area of the prism. So 3, add up the results to get the surface area of the prism. What do they mean there? That now this will be like the total area in that case, which will be equal to the areas areas of cross-section, areas of cross-section, then plus the surface side area or areas. So you get that area, the area of the cross-sections plus cross-sections, yes, area of the cross-sections, then plus the surface side areas, and you have the area of the whole prism, of the whole what? Prism. Okay, so that is it. Any question? Any question? Any question? Any question? Okay, if you have no question, I want you to write this up to this point here. Sorry, write surface area of a cuboid and draw this diagram up to this point here, up to here, up to here. Let me put red color, highlight with red, up to where I put red. So surface area of a cuboid up to the point where I put red, and then I'm going to get you after 2 minutes. So write that. So I hope you have finished. I hope you have finished. I hope you have finished. So let us look at how we get the surface area of a cuboid. That's the first rectangular prism that you are looking at. So we can say part A, surface area of a cuboid. And I think you have finished writing that, or you have finished drawing that. So I'm saying that a cuboid is a solid with 6 faces. Pairs of opposite faces are identical and equal in size. So how many pairs are there? How many pairs are on a cuboid? Let me ask. How many pairs on a cuboid? Put up your hand. How many pairs on a cuboid? Esther, how many pairs on a cuboid? How many pairs of faces are on a cuboid? Esther? Esther.
Yes, teacher.
How many pairs of a cuboid? How many pairs of faces of a cuboid are on a cuboid? How many pairs of faces are on a cuboid?
6.
There are 6 pairs. Wow. Members, have you heard there are 6 pairs? So it means that there are 12 faces. Esther, is it so?
No.
So how many pairs?
3.
There are three. There are 3 pairs. So we have this pair. We have this face here, and this other one. That's one pair. We have A, B, C, D. That is the second one, and E, F, G, H. Okay. Then we have A, B, F, E, the upper one, and we have D, C, G, H, the downer one. So there are 3 pairs. So I'm saying first is A, B, C, D, A, B, C, D, and E, F, G, E, F, E, F, G, H. And also this one, I've talked about them. Those are the identical faces. So if you want to find the area of face A, B, C, D, then you have to multiply length times the distance here, which is the height. Okay, so the height is not included in our diagram. So let us include the height there. Please draw the height and include it there. So this is the cuboid. I know some of you have drawn some funny diagrams there. Let me ask Wendy. I know you are good at drawing diagrams. I wish you can share with us.
Your volume is low.
My volume is low. Sandra,
Yes.
is my volume low right
It's
now?
better.
It's better.
Yes. Thank you.
Okay, we have this figure here, which I've already finished drawing. Like that. And then also I join this one there, like that. So very fast, this is A, B, C, and D. The distance in between is L. And then this is C, G, F. And the distance in between here is B. Whereas here the distance is height, H. Okay. So if we want to find the area of the face ABCD, and that area of that face is equal to the area of the face that is inside. So this face here, if I may shade this face here, okay, this face, its area is identical to the area of the one which is inside there, that area there, inside, okay? So this is E. So this face area of, can say area of A, B, C, D is equal to the area of E, F, G, H, which is equal to length times the height. Because if this is H, it means that also this one is H times H, which is LH. Okay? Okay, now area of the faces A, B, C, D, and E, F, G, they are going to be added together. So we add those 2 areas because we want to get the area of the 2 faces. So area of the 2 faces, that is A, B, C, D, and E, F, G, H will be equal to twice LH. So we shall multiply by 2, and that's why it's there. So you go ahead and find the area of this other side. Let's say these other ones, these ones which are this side, and EHD, AEHD, and BFDC. So we find the area of the next ones, area of let's say AEHD and CEFB, the same thing. So that area is also equal to base B, but times H, which is BH. So now the area of the 2, area of the two faces. I zoom out a bit. Area of the two faces, that is EHD and CFB, is given by 2BH, like that. Okay, so you're getting the areas, and then the area of this other one that is up, area of, let's say, AEFB and DHBC will be given by, what's that area? Given by this downer one and the upper one. It's given by B times what? B times L times what? L times B, which is LB. Okay, so area of the two faces of AE, B, FB, and CF, CF. So this was CB. So this is supposed to be D, DH, BC is 2LB. So now you can find the total area. So total surface area. You can do that. Total surface area. We can do that, and we shall have the surface area can be got as having this area 2LH then plus 2BH then plus 2LB. And then from here you can factor it out 2 and have